So welcome back once again to our interfacing videos, and in this particular video I'm going to look at how to interface or connect a 7-segment display to port B of the PIC16F84 microcontroller. Well, here's the circuit diagram shown here on page 7. Now what we've got is we've got port B, and we've got lines RB0, RB1, RB2, RB3, RB4, RB5, RB6 and RB7. So we've got pins 6, 7, 8, 9, 10, 11, 12 and 13. And they are going to be connected to this common cathode 7-segment display. Now, effectively, a 7-segment display is 8 LEDs. So here's the first LED called A. Here's the second LED called B. Here's the third LED called C. Here's the fourth LED called D. Here's LED E. Here's LED F. And here's LED G. Let's count them. 1, 2, 3, 4, 5, 6, 7. Now, sometimes there's also a decimal point associated with 7-segment displays, and that's called DP. Okay, now this is a common cathode 7-segment display. The cathode is the negative end of a diode, and the cathode always has to be connected to ground. So somewhere on our 7-segment display we'll have a ground pin, and we'll have to remember to connect that ground pin to ground. Okay, so what we've got on this 7-segment display is you've got LEDs A, B, C, D, E, F, G and the decimal point. And if I send a logic 1 here, LED A will turn on. If I send a logic 1 here, LED B will turn on. If I then send a logic 1 here, LED C will turn on, and so on. So as I send logic 1s and 0s out on pins 6, 7, 8, 9, 10, 11, 12 and 13 of the PIC microcontroller, these different segments on the 7-segment display will turn on and off. Now this is difficult to show on a slide, but when we do a Proteus simulation you'll see this actually happening. So what's actually happening, folks, or what we want to happen I should say, is we want to put logic 1s and logic 0s inside in this port B register, where they'll be transferred out onto pins 6, 7, 8, 9, 10, 11, 12 and 13. And what will happen then is the various segments will be either on or off. One strange thing about a 7-segment display is that it can be used to write numbers such as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we can get any number between 0 and 9 on this 7-segment display. But to do so, we have to figure out the code to display a 0 or to display a 1 or to display a 2. And that code is different for 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So the code 0, 1, 1, 1, 1, 1, 0, 1, that will display the number 6. So the number 6 will be displayed up on this 7-segment display if I send 0, 1, 1, 1, 1, 1, 0, 1 from port B to the 7-segment display. Now, in hexadecimal, 0, 1, 1, 1 and 1, 1, 0, 1 is 7D. So we'll be using these hexadecimal codes in our software to transfer different codes from the port B register to the 7-segment display to get different numbers coming up. Because port B is being used as an output port in this particular application, the TRISC-B register has to be loaded with 8 zeros. And again, we'll talk more about this when we're looking at the software side of things in a different video. So that's how to interface or connect the 7-segment display to our PIC microcontroller. Okay, thanks for listening.